Hello everyone, and welcome back to a new episode of Advent of Code. I decided I was going to try to do this one as the puzzle is released, and so I'm going to take a slightly different approach to this recording. I'm going to try talking less. Try to focus on getting a program out quickly. I don't think I'll be on the leaderboard. I'm not really that competitive, and I'm not like that familiar with how to do all the normal things in Haskell, and I don't know how to prepare a program skeleton that will fit well. But I thought it would be nice to try to like be done relatively quickly and then go back over and show you and explain the stuff that I didn't cover. So control.monad.trans.state.lazy, sure. So I put a couple things in here that I might want at some point, and if I don't, like, that's life. I have a map lying around, I have a state monad. If I need some other monad, I don't know, like, I guess I can get it, but let's go ahead and define parse as well. Let's say type input equals so far string. We don't know exactly. Words. I don't know. Parse equals identity. Why is part 1 wrong all of a sudden? Oh, I see. I don't know. We'll just sort of guess at what types we might want there, and we can come in and fix it later. The puzzle is, the countdown's almost over, so we're about ready to get started here. And we'll see. Like I said, I'm not super competitive, but I'm going to try to go through this a bit more quickly than usual. Large string blocks your path. There's garbage everywhere. Stream of characters. The characters are groups, sequences with curly braces. Within a group there are some other things separated by commas. Either another group or garbage. Okay, so this is balanced parens. Sometimes instead of a group, garbage begins with angle brackets. Okay. Got it. Some program has, this is like a XML CData parsing kind of. Some program has canceled some of the characters. Any character, so exclamation point causes you to ignore a character. So what is it we're trying to do? Find a score. Each group is assigned a score. Okay, got it. So the outermost group gets a score of 1. Okay, interesting. So we don't actually want a parser at all. Oh, let's get our puzzle input, shall we? Get out of here, Chrome. Oh, whoops, I forgot how to paste. There we go. So we're, okay. Do I need to store this in a group? It's probably a good idea. Do I? No. Actually, I don't really want to do any of this crap. Let's just write part 1 real quick. let's see. So when we're done parsing, we can just return the depth of the thing. There should go. This is looking a little bit dumb. I don't think we want all these like so if we parse a left angle bracket or left curly, we should increase the depth by 1. So sort of like go of depth plus 1 and more, I think, is all. This more is go more plus depth. We're closing a group here, so we finally score it. Oh, go more needs another argument. Go depth minus 1 more plus depth. Okay. So can we ever have exclamation points only appear inside of garbage? Okay. How do you score garbage? It just has no score at all, right? Okay, yeah. Garbage of this, cons to anything, cons to more, equal to garbage more, and garbage of this more is equal to go depth more. So what are we scoring? Are we scoring groups of garbage or groups of brackets? Okay, so the garbage, got it. Wait, is garbage comma separated? It is. Oh, groups are also comma separated? They are, okay. So we should, already have that clause. Okay. Why are we upset here? Multiple declarations of part 1. Okay, this looks promising. It compiles. Non-exhaustive pattern, line 18. Oh, of course. Non-exhaustive pattern, line 15. I'm back. You can tell I did not really prepare. I didn't consider that I might have to go to the bathroom while this was happening. Who knew? All right, wasted a little while there. But so we were running into non-exhaustive patterns at line 15, 15 to 21. Sure. So. So what is the problematic input that we're getting? 3 close brackets. Ah, right. We can have, okay. We don't necessarily have a comma here, so we can say go depth of this. Go this very same thing. Non-exhaustive patterns in garbage, really. So we had some garbage empty somehow? Oh, the same problem. The comma is optional. Still broken. What is it? Empty? It's just empty, I think. Right? Yes. So how did we get to the end of a string while thinking we were still in the middle of garbage is what I want to know. Let's go reread the problem. 0 or more things separated by commas. Groups begin and end with curly brackets. Between angle brackets, any characters can appear. Yeah, I know. The immediate character after an explanation should be ignored. So something's wrong in how we process garbage. Why? Our very first step inside of garbage is check for explanation points. So I think I'm quite happy that we have that right. We check for garbage groups ending next. What about left angle brackets inside of garbage? Is that allowed? We didn't think about that. Left angle bracket has no special meaning. Okay, so we're not treating it specially, that's correct. Maybe this would have been a better time to use parsec? I don't want to have to look up how to do it at the moment, though. I feel like this parser is, like, super close to correct. And there's just something I'm missing, and I'm not very good at finding it. So if we see a right angle bracket, we go back to the top level. We go back to go. Is that correct? I think so. Okay, well, let's try this out like, oops, I meant to do like this. Part 1 on like that. 3. Okay, clearly that answer is way too large. Probably want a 0 there. Yeah, that's more like it. How about that? So this is all fine. This is all fine. Still fine. Let's try the example input that they give us then, like a large one here. This should be sort of interesting, right? Copy. We get a score of 9. So that is correct. Oh, did I not copy my input right? This doesn't look correct at all. I think Chrome got upset with how... No, yeah, I see. Something went wrong copying my input, I think, is what happened. Well, okay, it's still wrong, though. There's still this A. What the heck? That's not what my input looks like. And it's not what it looked like when I wrote it here. Am I looking at... What is going on? Something bad is happening. Just in like how my SSH is copying the input, which makes me very sad. How do I fix this? Where does my input end? Nowhere useful. I guess I could just like grab this, or well, this, and search for it in the puzzle input and copy everything after that and paste it again. This seems ridiculous. That actually looks correct. And that gives me an answer. That's outrageous. How long did I waste debugging, like, the fact that I could not correctly copy and paste a file? Okay. Well, we got the right answer. Rank 528 for that star. So clearly, as I said, I wasn't expecting to make the top 100. But I'm kind of bummed that I wasted all that time on, like, my input being wrong, and I don't understand how that happened. No, I don't want to look at my leaderboard. I want to look at part 2. To prove you've removed it, count all the characters within the garbage. How many non-cancelled characters are within the garbage? Okay, so get day 9, part 1. Okay, so this is actually relatively simple. We just don't add depth in these cases. Non-cancelled characters. +1? Is that it? I think so. Okay, we got a different number. Oh, whoops, I didn't show you guys the answer. Okay, well, we got the right answer. Here's what I changed. I took out the plus depths. Actually, I can show you. Here's what I changed. I took out the plus depths on these 2 lines, and I just added a +1 here, since we only wanted to know how many characters of garbage there were. Now, of course, this is not a 2-part solution like I would like to do. And it's also, like, not a solution that models the problem domain at all, right? We don't have anything but like a single function that produces an int. There's no model of the problem that we can manipulate. This is not flexible, not adaptable, not really understandable very well. So this is the kind of thing I would only write in a race, sort of, so to speak. So we'll rename part 1 to solve, I guess. And commit this, but then I think go back and A, explain what I was doing here, and B, maybe write a nicer solution, just like to show. I don't know. I'm not so convinced that rewriting this would be that exciting. So the idea was, we don't actually need to count groups at all. We just need to track our running tally and how deep we are. Every time we close a group, we add to our score how deep we are, right? So that's why... Actually, let's check out version 1, since that was a little more interesting. Okay. We're tracking our depth. Every time we encounter a left curly, we add 1 to our depth, and then continue parsing. Every time we go up a level, we remove the comma if there is one, and decrease our depth by 1, but give ourselves a point for our depth. So that's pretty much like how we do that, but then it's like, okay, well, there's all this garbage that we have to ignore. And so this function just like notice, I guess, this is a little interesting. This is all, I guess, what you would call, yeah, this is all tail recursive, and I guess I will tell you what that means. I forgot how to mute. Help. All right, I had to do a manual override there with the mouse so I could get some good coughing in. So these functions are recursive, right? Go and garbage call each other, and they call themselves. And so if you're used to, say, Java or Python, you would expect that these functions on a large enough input will Stack Overflow. But in fact, our input is 13 kilobytes. If we had 13,000 stack frames, I think Java would break. Probably, right? Like, I don't know. It's close. Maybe. But I think a few thousand stack frames is enough to make Java sad, let alone a few tens of thousands. And so it has been known for a long time in computer science theory that when you call a function and you're going to do something with the result of that function, you do something like you push your current address onto the stack, and then you jump to that function's address, and at the end of that function, it jumps to it pops the return address off the stack and then jumps there. And so the stack sort of has to grow with the return side, with the number of recursive functions that are nested. But there's a particular case where you can optimize that away. If the very end of your function is to just return the result of a different function, then instead of pushing your own address onto the stack and then calling this other function and having it return to you, and then you pop the caller's return address off the stack and then you return to the caller, you can just jump to this recursive function's address directly without putting anything on the stack. And when it's done, it'll pop something off the stack and say, where should I go? And that will be the caller of your function. And it'll sort of bypass the middle frame completely. So this happens only if the last thing your function does is call some other function. But if that's true, then you don't need to use any stack space on it. And so Haskell and some other languages are built around taking advantage of this. One of the things they're built around anyway. And so all of these recursive functions actually are not taking up any stack space. We're just sort of, this is how you write a loop in Haskell, in a way. Normally, of course, you do it with like a higher order function like a fold or a map or something. But if you want to write a loop by hand, you do it with a recursive function that just calls itself after doing something interesting. After computing some new, more simpler parameters for itself, where here simpler means there's fewer characters left to read. And so the same, like Go and Garbage, both do this. They both, the last thing that Go does in every case is call either Go or Garbage. And likewise, the last thing that Garbage does, indeed the only thing it does, is call either Garbage or Go. Except these error cases, right? Or in the one case here, where Go actually returns something. When we're done with the string, we should stop looping. So anyway, I think that the pattern matching here is actually relatively straightforward. You can look at it and say, oh, okay, yeah. So when parsing some garbage, you first check if the garbage is skippable, and if so, you skip it without doing anything. Then you check if the garbage is over, and if so, you go back to the top level where you're counting stuff. And otherwise, you just ignore the garbage character. That's sort of it. better, I think, solution would be something that looks a lot like this, but instead of just computing a number, it would be building up a tree. And so garbage would return, say, a list of characters that were actually included, which, a string, basically. Garbage would return a single string, which is, here is the contents of this block of garbage. And the Go parser thing for the top level would return a tree, some data structure we have built of blocks of either garbage or subblocks. And then we would eventually have this tree at the top level that is a block, and its lower level has some garbage and some blocks recursively, and then we would write another function that traverses that tree and computes the two different scores. I think that would be much cleaner than what we've done here, but it certainly would also be much longer. It would be more adaptable if someone were to say, gosh, what would be a difficult question for someone to ask here? What if they said, how many times inside of garbage does the string A, B, C, D, E, F appear? Not counting where you skip over the characters with this exclamation point saying that you shouldn't count them. It would be quite hard for us to retrofit this in here, wouldn't it? Like, we'd have a lot more to track suddenly. And all the tracking we're doing out here would do us no good. Whereas if we had a tree of just like, here's all the groups and here's all the garbage in them, we could just write a function that extracts a list of all the blocks of garbage at any depth and map a function over them that scans for ABCDEs and then sum the results, and it would be pretty simple. So I think that, like, I don't know. Usually I prefer writing good domain models to churning out a solution quickly. It's fun to do this for a change, but it's not really why I write Advent of Code, why I participate in Advent of Code. There are people who do. They have a lot of fun. I mean, like, let's look at today's leaderboard. How fast do people do this? My bet is under 1 minute for the first one? No, let's say under 2 minutes. Oh, no one did even close to that. Interesting. So I know the first couple of days, the first solutions were outrageous. Oh, hang on. The first solutions were outrageously fast. Like under a minute, I think. But so for today, the best solutions were under 5 minutes. But not very many of them were. How did I do? How do I find that out? Stats? No. Leaderboard. Personal stats. 21 minutes. Okay. That's like 2150. I mean, it's not outstanding or anything. And it's not, even if I hadn't had to step away for a while, I would not be close to the leaderboard, but I'd be kind of up there. I don't know. Anyway, my point is that, like, this is all cool and stuff, but I sort of write to practice writing good programs and not to practice writing quickly. I find that more fun. Okay, anyway, well, I guess we're done today. So hope you guys enjoyed this slightly different take on Advent of Code. I'll probably go back to doing it slow, but anyway. I keep just saying that and then saying we're done and then going back to that. Shut up, Alan. Just say thanks for watching, and I'll see you next time.